move on to the next speaker, who is Peiyuan Chen from Chalmers, who is actually doing research within 2 different projects on microgrids and some technical aspects. So, welcome.
Thank you. My name is Peiyuan. I'm a docent at the Chalmers working on electrical power systems. So if we think about, let's say, distributions like 15, 20 years ago, I mean, the original purpose of medium voltage or low voltage distribution system was simply to deliver electricity to customers. So that's the main purpose. But then 15, 20 years ago, we start to integrate a lot of renewable generations in this distribution system. Then we talk a lot about, okay, what's the hosting capacity of this distribution system at that time? And then we were saying, can we use these wind turbines or PV converters to provide reactive power or voltage controls to increase this hosting capacity? And then recent years, we even talk about, can we provide flexibility or ancillary services from the distribution system? And there we were talking about active distribution systems. So from 15 to 20 years ago, we have a relatively passive distribution system, and now we move to a quite active distribution system. And then now we are talking also about how the possibility of doing island operation of this active distribution systems, and then we call it microgrids, right? So our project's focusing very much also, we were taking a step further. If we have one microgrid, and then you have the adjacent microgrid, can they work together? So this is what we call interconnected microgrids. And so this is one of the projects that we're talking about when we're looking at the interconnected microgrids. Then the first question we ask ourselves is that, okay, which type of grids actually make sense to interconnect together? Of course, they have to be geographically close, otherwise it will be too costly. But if you connect, let's say, a commune with another commune, that they have a really similar load profile, then it probably doesn't really help to interconnect together, because you wanted to sort of, in a way, share resources between 2 different local grids. And then the second question that we try to ask ourselves is that, what technology should we use to interconnect these 2 different grids? Should it be an AC connection? Should it be a DC connection? And then we also comes to looking at, okay, since now we are looking at the local grid, so it's no longer electricity, but also can we utilize something from the heat sector? Can we co-optimize the energy distribution? And is this something we can use from the flexibility we can extract from the heat in buildings, for example, or our transport sector, since we have a lot more electric vehicles coming up? And so these are the questions we think that how can we optimize the operation of these local microgrids, even when they are working grid connected or island mode. I mean, if you think about the whole transmission grid, it's actually also an island. It's just a bigger island. Then we are looking at just a smaller island. And in this case, also compared to the transmission system, we are also a bit more small, but more agile. So can we actually, and then one of the questions we look into is also that, should we copy what we do in transmission system and do it in the distribution system? Or is it a smarter way that we can actually work with this distribution system when they are in island mode? So I think I will leave the talk for more discussions later, and that's the end of the speech.